says solve using the quadratic formula. Okay, so in order to use the quadratic formula, everything has to be on one side. Even if we weren't using the quadratic formula, everything has to be on one side if it's a quadratic. Okay, now that p, that 1p is going to move over to the left. It's going to go right in the center and it'll become negative. It has nothing to pair up with. And then remember, for quadratic formula, you want to identify a, b, c. So a is 4, b is -1, and c is +5. All right, so p would equal the opposite of b, which is +1, plus or minus, and then under the radical, this is where we have the original value of b squared minus 4 times a, which is 4, times c, which is 5. And then on the bottom, you'll have 2 times a, so 2 times 4. So that's the setup. Now, using your calculators, if you were to type in this stuff right here, you should get a negative number. -79. And then on the bottom we have an 8. Okay? Now if you were to look at your factor sheet and you look at the row of 79, 79 doesn't break down at all. But are we allowed to have negative numbers under radicals? No. To get rid of the negative, what do we move out front? The letter I. So I'm going to put the letter I in front of the radical, and then I'm going to leave the 79 under the radical. And because of this reason here, the 1, and the 8, you can't reduce those. So as soon as you move that I out front, that problem's actually done. It's all finished. Okay, now problem number 2 says solve by factoring. Okay, so when you look at problem 2, do those two terms have anything in common? Why, yes. Yes, they do. They're both divisible by 3, and don't they both have a p? Okay, so we're going to put a 3p out front, and then in parentheses, if you were to divide both terms by 3p, you have p minus 4. So then we're ready for our two answers. Because if you have 3p out front, set that equal to 0, wouldn't you just get 0? Because 0 divided by anything is 0. And then what would this set of parentheses give us? If we took p minus 4 and set it equal to 0, p would be positive 4. So p equals 4. There are your two answers for number 2. Are we good? Good? Okay. Number 3, we've got a quadratic and they want us to graph it. So this is a parabola. In order to do that, this is not vertex form. So since this is standard form, we have got to find our axis of symmetry first. So I'm sure you guys remember that little formula, that x equals negative b over 2a. Opposite of b, so the opposite of 12 is negative 12. That's what would go up top. And on the bottom, it's 2 times a, which was negative 2. So what is 2 times negative 2? And then negative 12 divided by negative 4 is positive 3. Now remember, that's just the x, and we need a vertex, and our vertex will start with x. So we know that for our vertex, it's 3 comma something. Well, how do we find y? Always. How do we always find y? Okay, so see this function up here. We're going to take this function, -2, but then wherever I see the letter x, I'm going to replace it with a 3. So you have an x in 2 different places. I gotta move this over so you guys can see that. There you go. So right here is the work. This is just the original function. And like I said, I replaced the x's with 3's. And then that is just a matter of, you know, type that whole thing into the calculator, see what you get. And you should get 3. Okay, so now we have our vertex. So now we have at least the vertex, which is our starting point, that we can go ahead and plot. So we're going to put a point at 3 comma 3. And then anytime we graphed parabolas in the past, I always said draw in, you know, that dashed line, which is your axis of symmetry, just so you have something to like mirror the points across. Now, if our vertex is at the top of my t-chart, and that's at 3, what other 2 x values can we use? We could use 1 and 2 or 4 and 5. It doesn't really matter. We'll do 2 and 1 just because I heard those first. Now, the good news is, can you guys look up here? You already have this typed into your calculator once. So all you're going to end up doing is you're going to replace those 2 numbers with 2's, and then you're going to replace them both with 1's. So the 2 would give us a 1. Yep. And then the 1 gives you -5. Yep. Okay, so then we're going to plot those points. You're going to plot 2 comma 1. And 1 comma -5. So if you guys look up at the board, you've got the left side of your parabola right here. We just need to mirror these across the axis of symmetry. So I'm going to put this one at 4, 1, and then this one would be at 5, -5. And you just want to connect them. Remember, this is supposed to be a U, so you want to try to make the top of it curved. Okay, are you guys okay with that? Okay. Now number 4, we haven't done one of these in quite some time, the interval notation. It's been a while since we saw this, and I don't know if you remember this or not, but greater than is always an and problem. So remember, when you have inequalities like this, you either have to shade like out or in. If it's an or problem, you shade out in opposite directions. And so your interval notation at the end looks kind of weird because you have to have the two different pieces. When it's an and problem, it's a lot easier because we're just going to have the two numbers that are our end points, and you would just shade between them. So all you guys have to do is just factor this side. We're going to factor this side like we always do. 3 and 4. What two numbers multiply to give you 3 that add to give you 4? 1 and 3. So if those are the two numbers, the two factors that are in parentheses, when we set that equal to 0, if we were to break them apart, what would our two answers be? So you have x equals -1 and x equals -3. Okay, so the interval notation, see how there's an equal sign here? Because there's an equal sign, they're the square brackets. And you're always supposed to put the smaller number here and the bigger number here. So it would just look like this, -3 to -1. That right there is your interval notation we're going to look for at the end. Now, listen, I'm going to make a little note on here because I honestly don't know what type you're going to see on your final. But if that had been an OR problem, okay, can you just watch? Make sure you watch this, Caleb. If this had been an OR problem, meaning that we're less than, like let's just say it was less than or equal to, then my interval notation, remember, it would have been from like -infinity to -3, and then it would have started at -1 and gone to positive infinity. So whenever you have infinity symbols, you can't use the square bracket because it's infinity, so you just use like the parentheses, but these would have to be square because of that equal sign. So that's if it had been a less than problem. Like we still would have done this part the same way. You still would have factored and gotten two answers. But if it had been or, you're shading out, so you would have had two separate pieces there. If it's greater than, it goes between. So you just have the one interval notation, okay? All right, go ahead and turn the page. Okay, now the next one says, the path of an object can be modeled using the equation y equals 2x squared minus 5x, where x represents the time and y represents the number of inches that is moved. So how long would it take an object to move 3 inches? Okay, well, didn't they just say that y is the number of inches? So right here is where we'd plug in the 3. And they want us to solve for time, which means they want us to solve for x. Well, in order to solve for x, doesn't this have to be over here? Okay, so if I move that at the end, wouldn't it become negative? So 2x squared minus 5x minus 3. And then we'll factor. All right, so we've got, remember up top you have to do the a times c, so -6, and at the bottom -5. And instead of 1x and 1x, we now have 2x and 2x. Okay, what numbers? -6 and -5. -6, +1. Okay? So one set of parentheses is 2x plus 1. Now the other set, what would this reduce to? So x minus 3. Yep. Now before I solve each of these, I just want you to think with me. Remember, we're solving for time. So doesn't our answer have to be positive? This one's going to give me a positive 3, won't it? Is the other one going to give me a positive answer? It's going to give me -1/2. And we can't have time be negative. So this one I'm not even worried about. I would just cross that one out, because that's going to give us a negative answer, and we cannot have negative time. Number 6 is a big problem. And there is not even close to enough room on here to work it out. I mean, I was able to work it out on mine, on the copy that I did over the weekend, but it's a lot of work. Because if you guys look, this one only has 2 letters. See how this top equation only has 2? And then the bottom 2 have 3. Well, okay, look up at the board and watch what I'm pointing at. This equation here does not have a y. So if I have to pair these 2 up, I have to make the y's cancel out. Because if the y's cancel, then I'll have x's and z's, and I can pair it up with that top one. Okay? So I'm going to try to make this fit, but you guys are going to have to follow along. Nope. We need to make the y's cancel. So if this is a positive 2 and this is a positive 1, what could I multiply positive 1 by to cancel positive 2? Okay, we're going to multiply that bottom equation by -2. So I'd have 8x minus 2y minus 12z equals -32. And then we can pair up the one that was above it, the 1x plus 2y plus 2z equals 8. Now, if this were me and I was taking my final, I would be working some of these problems out on paper, like notebook paper, because there's just not enough room, and because it's a PDF, like a file, I cannot edit it to spread everything out for you guys. So tomorrow when you guys are taking your final, please don't hesitate to use separate paper, like a separate sheet of paper if you need to.
Do we still have to turn it in with it?
Yes, yeah. Okay, so if I put these 2 together, my y's cancel, and I end up with a 9x and a -10z and what, -24? Okay, so now you have to think. So you guys might want to look up here. I have to put this equation with this one, because they are the 2 that just have x's and z's. So I either need to make my x's cancel or my z's. So I could make, what, both of these 18s? This could be a -18, this could be a positive 18. Let's do that. We're going to multiply this top one by 9, and we'll multiply this one here by 2, and that'll make stuff cancel that we need canceled. Okay? So if I multiply that top one over there by 9, I would have -18x plus 36z equals 144. And then I'm going to bring this one over and double everything, so that'd be 18x minus 20z equals -48. And we will finally have our first answer of z. So 36 minus 20 is 16z. And then over on this side, we'd have a 96. 96 divided by 16. Finally have our first answer. Now the good news is once you have your first answer, to find the rest, it goes pretty quick, because to find the rest of them, you're just plugging these numbers in. So like, if that top equation, this one up here, you might want to look, I'm going to highlight it actually. That top equation that said negative 2x plus 4z equals 16, I could go ahead and plug that 6 in where the z is, and I can solve for x. So that's what I'm going to do. I'm going to take this over here, and I'm going to do a negative 2x plus 4 times 6 equals 16. So we're just doing a plug and chug. 4 times 6 is 24. And then that's just a two-step equation, so you guys would subtract and divide. So I'm getting x to equal 4. I said it's a big problem, because we still need y. And just so you guys know, I'm going to use this middle equation, this one that I'm highlighting in pink. That one has x, y, and z. And if I need to solve for y, I have to plug these two numbers into an equation that has all three letters. So that's what I'm going to do. So we have x, which is 4, plus 2y, plus 2 times z, which is 6, equals 8. Now that's a lot of stuff up there, but that's the kind of problem it is. What is 2 times 6? This is 12. And 12 plus 4 is 16, right? So I just went ahead and combined that to make 2y plus 16 equals 8. Then it's just subtract and divide. And then we'll finally have our last answer and be done with this problem. Oops, that is not right. I can't do math. What is that? Negative 8. Yeah, sorry, I messed up. That's negative 8. And then divide by 2 and you get negative 4. We finally have all three. And once you have all three, remember you're supposed to put them in a set of parentheses. And it would be x, comma, y, comma, z. So my x was negative 4. Oh, no, it wasn't. My x was 4, the y was negative 4, and the z was 6. So 4, comma, negative 4, comma, 6. While you guys are finishing that, can you do me a favor? Can you look at problem number 8? And can you guys change that 11 to a 10? I'm not exactly sure. When I look at the answer key, it shows that it works out, but I was not getting it to work out. So we're gonna just switch that to a 10 because it works with the 10. So I'm not sure, unless I'm just crazy, but I couldn't get it to work. All right, now number 7. 7 says to solve using substitution. Okay, so watch. Look up here. See how this says y equals and the y is by itself? We're going to take this piece, the 2x minus 1, and we're going to plug it into the bottom equation where that letter y is. So I would write negative 8x plus 8, but then instead of putting the letter y, you're now going to plug in 2x minus 1. Yeah, you actually do that back in Algebra 1A. Algebra 1A, you learn how to take an expression and plug it in. That's the first time you probably would have seen it. And then you've seen it in here.
I actually did know it in the assignment today.
Yeah. Okay, so now we can actually solve this equation because there's only x's. I'd have to distribute 8 times 2x is 16x, and 8 times negative 1 is negative 8. And then we can put these two together. So a negative 8x plus 16x is 8x. So you get 8x minus 8 equals 0. We'd add 8 and divide by 8. What is 8 divided by 8? 1. So you get that x is equal to 1, but we still need y. But this is the easiest part. See that little box right there? See that little box I drew at the beginning? If I plug my x in right here, then I'll get y, because it says y equals that. So y equals 2 times x minus 1. Well, what is 2 times 1 minus 1? There you go. They're both 1s. So our ordered pair would be 1, 1. Phew, that's a lot. Just also squished in there. That's fine. I was just shrinking it down so you could actually see all of it. Ready? All right, so right here, if y equals this quadratic and y equals this linear, then when we did this lesson, it was set the quadratic equal to the linear because they're both equal to y, so we can set them equal to each other. And with all quadratics, don't these have to move over? So we're going to add 3x, and we're going to subtract 4. And when you do that, you end up with x squared minus 5x plus 6 equals 0. So we are looking for the two numbers that multiply to give us positive 6, but add to give us negative 5. Yeah, change that 11 to a 10. So here's the thing, if this would have been minus 5x plus 7, the only way to make 7 is 7 and 1, and it wouldn't have factored. So I think something is not right on the answer key, unless I'm just missing something, but
That's just something else.
Yeah,
-3, +2.
-3, -2. They're both negative. It's -3, -2. So that's going to give us two different x values. What are my two x values going to be? +3 and +2. Okay, so I know one ordered pair starts with 3 and the other ordered pair starts with 2. What I don't know is the missing y value for each. So to find the y, hang on, look at the board, please. To find these y's, I'm going to take each x value and plug it in right here. So I'm going to do -3 times 3 plus 4 and -3 times 2 plus 4. So -3 times 3 plus 4, and I'll put that answer here. And then -3 times 2 plus 4, and I'll put that answer there. Can you guys tell me what they are? Yep. Those are your two ordered pairs. Okay, now the word problem, we just have to write our own system, but then we're going to use elimination to solve it. So we have vans and buses. So I'm going to use V and B. So we have senior class at high school A had 13 vans and 1 bus for a total of 180 students. High school B was 6 vans and 10 buses for a total of 436 students. Okay, so setting up the system really isn't too difficult. You just base it off of what they're telling you. Whatever, like if they're vans and buses, it made sense to me to use V and B. You can always use X and Y if you want to, but okay, now look, we have to make one of these cancel. Off the top of your head, do you have any idea what 6 and 13 can both be turned into? Probably not. But if this is a 1, can't I make it a -10 to cancel with a +10? Yeah, we can just multiply this top equation by -10, and we'll get the b's to cancel. Guys, when you multiply by 10, it just adds a 0 on the end. So you don't even have to like type it in. This would become -130v. This would become -10b. And this would become -1800. Obviously that only works with 10, but that'll save you a little bit of time. Now I don't have to change this bottom equation at all. Now you guys are going to have to do some calculations here with the calculator. Like -130 plus 6 and -1800 plus 436. negative 124V. And then what's the other side?
Negative 1,365.
Yep. And then we'll divide by negative 124. So my answer that I'm about to get is how many students fit inside each van? 11 students. Okay, so that's how many students fit inside each van, but we still need to figure out how many students fit in each bus. So you have to take that 11 and plug it in somewhere. Well, this one's going to be the easiest because there's a 1 in front of the B. So which means we won't have to divide at the end. We can just plug in that 11 where this V is. So I would do like 13 times 11 plus 1B equals 180. So I just plugged it into the original equation. And then we'll just subtract 143. $37. So that means that 37 students will fit on each bus. And then that problem's done. One page down, 3 more to go. I'm not going on. Good news is, those problems that we just did required a lot of work. The rest of this, not many of them really require a whole bunch of work. So I would definitely say that first page by far is where the majority of stuff happens, like the majority of the work that you guys actually have to do. Now, I'm not saying you won't have to do some work on the other ones. It just requires less work. Most of them. Like if you look at, while we're waiting for a minute here, if you look at number 10, 10 just says, determine whether the scenario involves independent or dependent events, then find the probability. So that's literally just multiplying two fractions together. Number 11 is real easy too. It's a composite, and sometimes those composite functions can be difficult, but that one's one of the easier ones because you're just plugging H into G. Good? Okay. So number 10 says, there are 5 boys and 7 girls in a class. The teacher randomly selects one student to answer a question. Later, the teacher randomly selects a different student. That word right there is extremely important. To answer another question, determine the probability of the first student being a boy and the second student being a girl. Okay, so first of all, how many total students are there? Okay. So when the teacher first picks a student, there are 12 to choose from, and how many of them are boys? Okay. So the first fraction's real simple. It's just 5 out of 12. The second fraction, it said that the teacher specifically picks a different student. So can that one boy be included in that total? No. So instead of there being 12, now we're just choosing from 11 students. And how many of those 11 are girls? 7. Now, if it had said another boy, wouldn't we have to decrease the 5 to a 4? Because one of the boys had already been picked and it has to be a different boy. Okay, so This is it. And if this bottom number decreases, doesn't that automatically mean it was dependent? If it was independent, we'd have a 12 both times. So this is definitely dependent. It's a dependent event. And then you guys just type that in. Type in like 5 divided by 12 times 7 divided by 11. 0.265. There you go.
That's a weird number.
Well, it's always going to be, we're usually going to write it in decimal form. And when we do decimals, I usually ask you guys to carry it out 3 digits. Okay? All right, number 11. So look up this right here. The H is what is going to be plugged into G. Okay, so now look at G. See how it said negative A? See how there was a negative sign? That's technically like having a -1. And then where the A is, what are we going to put in its place?
2a squared
Keep going.
minus 3a.
Yep. And then I still have to write the -2. So this is all you're doing. You might want to look at the board to make sure you understand this. You are using that top function, but you are plugging this in right there. So you are picking this up, putting it there, but then everything else about it stayed the exact same. Okay, so if I have a -1 out front, what do I need to do with it?
Or subtract, add it to this one.
No, this is not an equation. Distributing. So we're just going to multiply by -1. So it'd be -2a squared plus 3a. And then the -2 at the end. Can any of those combine? Nope, there's your final answer. See, that's one of the easier composite ones. You just plug it in, distribute, and then you're done.
Come on, Chloe, you should know this.
Brittany. Apparently you're Chloe now.
I mean, Brittany.
I don't know who Chloe is, but
I confused things. Sorry.
all right, number 12. How do we, for number 12, when you guys have absolute value, we have to get that absolute value expression completely by itself before we separate it. So how am I going to move that -2?
Add it to.
Yep, add it to both sides. Now, listen, can you guys look up, please? If there had been no symbol right there, okay, look, if that had been a -2 up against the bars, you'd start with division. That's how you'd get rid of it, but it was, we're just canceling it out here. So the absolute value of v plus 8 equals 13. Now, once that absolute value is isolated, what do I do? No, you're thinking the wrong thing. We have to write 2 separate equations. One of them looks just like this, just no bars. So we'd have v plus 8 equals 13. What does my other one say?
V minus 8.
V plus 8
Oh,
equals
equals negative 13.
-13. Yeah, the expression inside the bars never changes. Okay, now what? They're each just one step. What's my one step? Yep. I'll get 2 different answers, and they're not going to be opposites of each other. They're just 2 completely different answers. This one over here, I'd get 5. And this one over here, we'd get -21. And that's done. Good? Okay. Next problem, number 13. Okay, this is absolute value. We still need to identify the vertex, so let's see if you guys remember. The number in the bars with x is your x coordinate, but that one always becomes the opposite. Okay, so this one will always become the opposite. So my x is a positive 4. Now, the number that's usually out here, that's your y, and that one always stays the same. Well, if there isn't one out there, what number is it? 0. So my vertex is at 4, 0. So the very first thing I would do is I'd go ahead and I would do 4, 0. I'd put my point there. Now, do you guys want to use 2, 3, or 5, 6? Okay. You could use 5 and 6 because the 5 will match the 3 and the 6 will match the 2, but it doesn't matter. So then when you guys do this, you can't type in absolute value into the calculator, so you kind of have to do this, like we're going to talk it out. So listen to me, please. You're going to do 3 minus 4, which is, and what's the absolute value of negative 1? And 1 times negative 3? Negative 3. There, I wrote it out. This one here, 2 minus 4 is negative 2. And what's the absolute value of negative 2? Absolute value of negative 2 is 2. So negative 3 times 2 is negative 6. So then you'll just plot 3, negative 3 and 2, negative 6. And then we'll mirror them. So 3, negative 3, 2, negative 6. So then I'd have 5, negative 3 and 6, negative 6. Now, absolute value is supposed to make a V. So you would want to go ahead and put your ruler down and connect these because it's a V, so they should all fall on a line. For the parabola, we couldn't use a ruler because it's a curve. So you just connect them, and it should be an upside down V. And then when you're ready, we're going to do number 14. Okay. So for number 14, we've got an x as a denominator, and then we've got this x squared plus 4x. But if that can be factored, we're supposed to factor it. And that's a GCF. Like they both have an x in common. So you'd have x times x plus 4. Okay? So if I were to say what's the common denominator, wouldn't it just be x times x plus 4? Because this is already an x. Okay, so if this is the common denominator, this is what I'm going to highlight. This one right here already has that as its common or as its denominator, and so does this one. So the only piece that's going to change is this middle one, because what you're supposed to do is you're supposed to squeeze this in up here next to each term. But if I put this up here, wouldn't this just cancel this out anyway? And if I did it down here, same thing. This would cancel this. So my 5 and my x minus 4 are going to stay the same. The only piece that changes is this one in the middle. It already has an x, so this x would cancel this, and all that would be left is the x plus 4. So we have 5 plus 2 times x plus 4 equals x minus 4. And then we just distribute and solve. So I have 5 plus 2x plus 8 equals x minus 4. I'll combine the 5 and the 8 to make 13. And then we just solve from there. So I'm going to move my x this way. So 1x plus 13 equals negative 4. And then I'll subtract 13. So I get x equals negative 17. And it's multiple choice. Honestly, looking through your final, a lot of your problems are multiple choice. But, I mean, just because it's multiple choice doesn't mean that you don't have to do the work. Because none of these can be done in your head. So I will still expect to see the steps on your paper and all the work to be shown, instead of just randomly guessing one of the 4. What's the matter? The synthetic division? Yeah, you can go ahead.
The one where you do like the 4 box.
Mm-hmm. 1, 2, 3, 4 columns and 3 rows. Yep. So 1, negative 1, negative 14, and 25 across the top. And then it's always this, the opposite of this number is the one that we use for the multiplication. So right now, all that I've done on 15 is set it up. Now, if you don't remember the steps of synthetic division, once you have this set up, it is always just multiplying and adding. So whatever number's at the bottom gets multiplied by the one out front, and you put it in the next column. And then you add going up and down. And then you do the multiplication again. Then you add up and down. And then you do your multiplication again and add up and down. So you should get 1, -5, 6, and +1 across the bottom. And when you go to write your final answer, if the original problem started with v cubed, this one is going to be 1v squared. You always drop down 1. And then we would have minus 5v plus 6. So then what does that 1 represent?
That's the,
Remainder.
yeah,
So it goes up top.
and then v plus 4.
V plus 4 goes on the bottom.